All right, so systems of nonlinear. Bless you. I'm going to show you the algebraic way because I'm pretty sure at this point we can find intersections on the calculator. Easy peasy. Which one do you guys want to start with? Left or right? Left? Why not? All right, so you could use substitution, you could use elimination. I personally, with some of these, because I'm afraid if you guys try to use elimination, you're going to try and cancel out things that you shouldn't, like an x term with an x squared term. So I personally went through and used substitution just because elimination kind of freaks me out with the whole, you're going to start trying to combine crap that can't be combined. So I would take this first equation, and I would say negative y equals negative 3x minus 2. And notice if they're all negative, I can either change them all to being positive, or can I plug it in exactly how I see it right now? Because it's negative y equals that crap, so why not? 2x squared minus 3x minus 2 equals 0. Now I can factor. 2 times 2 is 4. Factors of 4 are 4 and 1. So 2x squared minus 4x plus x minus 2. So now I've got my two solutions. I've got my first one where x is 2 and y is something, and then I've got my other one which is x is a negative 1/2 and y is something. So go to the drawer back by the door. All right. So now that I've got these solutions for x, can I just plug them back in? All right. So y would equal, this is where I would kind of go through and like, all right, now that I've used that, change my signs. So 6 minus 2 gives me 4. And then negative 1/2 times 3 is negative 1.5 plus 2 gives me positive 1/2. Woot. Easy enough? All right. Oh, yeah. Should be 8. Not 4, 8. All right. That second one, how do you guys want to handle that? I would just change that second one. So the second one becomes x squared equals y plus 7. And then I would just replace the x squared with the y plus 7. Because then it's in quadratic form and I can factor real quick. So then I got y squared plus y plus 7 equals 13. And then does it kind of help to split and write it as two separate coordinates so that way, because you do have to keep the x's and the y's together. So I've got a solution where y equals negative 3 and another one where y equals 2. So then I've got x squared equals negative 3 plus 7, so x squared equals 4. Yep. Square root both sides, and I get what? Positive and negative 2. So, there's the potential for having 4 solutions for this. All right, and I put the plus or minus 2, like 2, -3, -2, -3. All right, if I plug in this one, I've got x squared equals 2 plus 7. So x squared equals 9, plus or minus 3. Yeah, I'm okay with that. Because in my head, I know that's 2 points, so I'm cool with it. All right, ready to keep going? 8 answers? Yeah, you would have really, really complicated parabolas. Like more circles and overlaps and stuff like that. Ugh. I'm not giving you anything that gross. All right. So here are the next 2. Yes, they are gross. And if you want to see how truly disgusting they are, you can actually go in the book and see the graphing solution for them. Because they are hefty. All right, which one do you want to start, left or right? Yeah, I would go left. So for the left one, can I multiply this entire thing by x? So when I multiply it all by x, that gets rid of my fraction. So I've got x squared plus x plus y squared minus y equals 0, because 0 times x is still 0. So I can actually use elimination on this one, because I can cancel out a lot of really gross crap. All right, so I've got my original, x squared plus x plus y squared minus 3y plus 2 equals 0. And then I'm going to take that bottom one that we did, and I'm going to multiply it all by a negative, so I can cancel crap out. So I've got negative x squared minus x minus y squared plus y equals 0. And you see how I try to keep everything lined up? That way I'm sure I'm not trying to cancel out crap in the wrong spot. So what ends up canceling? Yeah. First terms cancel, second terms cancel, third terms cancel. So I've got negative 2y plus 2 equals 0. So negative 2y equals negative 2. So y equals 1. Is that a lot less gross than we were expecting it to be? And then I personally would probably plug it into that second equation. So with that second equation, I get x squared plus x plus 1 minus 1 equals 0. What happens to the ones? They cancel again. So x squared plus x equals 0, so x times x plus 1 equals 0, so x can either equal 0 or x can equal negative 1. Now the question becomes, if I look back at my original, could x actually equal 0? No. So this one's actually extraneous. That one's okay. Gross, gross? All right, what about that second one? You guys want to try that with me? You want to try it without me? Without. I'll give you a hint to start. I would use elimination, and I would multiply that top equation by 2. Yeah, it's under the candy. Sure. There are a couple Kit Kats in there. Oh, yeah, I forgot that one. That should be 2. So how many of us got to something like this and we got stuck? Yes? Anybody think they got to an answer? Possibly. What'd you get? Okay, so you plugged in x equals 0 and found y equals 1. Does that work for both equations? Yeah, I don't think that's going to work for that second one, because that'll just be 4 equals 10. All right, so could I get y completely alone on that second, like that bottom rung? Like if I divide by x, so I've got 3x plus 2y equals 2 divided by x, subtract 3x, I'm going up here. I got y to equal something. Little gross. Could I now plug in for that y and solve for x? Oh, it's going to suck. I would plug in on that second equation, just because I can get rid of a y completely. So I've got 9x squared plus 4 getting a little rough. So could you just be like, okay, I know y equals this, and I know x and y equal this. Could I now do y1 equals y2? And solve for x's that way? A little bit. Because if you try to follow the book ends up wanting you to do the quadratic formula with letters. Yeah, Sullivan's on something. Sullivan's always on something. But does this make life a little easier? Okay. Because if you look back at the original one and you try to get it so it's y equals to try and type it into the calculator, that's not going to fly. Like, especially with that top equation, because there's y's on both, that's going to be real icky. All right, and you should get, I think the book has 4 total solutions for it. Yeah, it's gross. No. I would not give you anything quite this gross. But once you do this, you should get the 2x solutions, which I believe are like positive and negative square root of 2. Yeah, let me double check. Nope, positive and negative 1. And then positive and negative, I think it's square root of 2 over 3. And then once you've got those two, you would plug them back in and solve for y. But yeah, I'm not giving you anything that gross on a test. Yes. All right. Not horrible. A little bit of algebra, a little bit of graphing calculator. Just try to be as lazy as possible and get through it. And know where our, like, could I do this algebraically? Yes. Do I want to? No. Totally different situation. All right. Can I scroll? I think, what all do we have left? Nope, just this one. And no, I didn't print it. So first period was very upset that, first of all, who runs that much? But they're each running at different constant speeds. No. So, we ended up drawing little stick figures. Alright, so, we'll do finish over here. Alright, so, first place homie. He finishes all 50 miles at some time, right? Yep, so he goes all 50 miles at time for the first period, and we'll say his speed is rate for the first person. Okay? T1 and R1. A little bit of physics flashbacks now? Yep, sorry. It's not as bad as when it's in physics, I promise. All right, second place was 1 mile behind. So he went 49, well, hang on, I gotta change my color. All right, so second place went 49 miles in the same time, but at a different speed. Okay? And then we've got our third place dude, who's way back here. What color have I not used? And he was what? First place was 4 miles ahead, so that's still 3 miles behind second place. So he ran 46 miles. Same time, different speed. Yes? You guys are just like, make it end. Okay. So, like, if you were going to make a system, I've got first place dude with a distance equals rate 1 times time 1. Second place dude, let's actually write this in the same colors. So, first place equals time 1, rate 1. Second place is 49 equals time 1, rate 2. And third place is 46 miles, time 1, rate 3. All right. So we're assuming that this runner maintains a consistent speed throughout this race. First of all, it's 50 frickin' miles. You're not maintaining a consistent speed over 50 miles. But we're living in the world where, you know, people buy hundreds of pineapples and stuff. All right. We're trying to figure out how many miles are between the second and the third place runner as they keep running. All right. So I know now that this second place dude, he is going to run all 50 of those miles with some different time, right? So we'll call that time 2. And that's going to be at his same rate. All right, and then I've got some distance for our little purple dude. All right. Now, I got a question. If the first three all have the same time, could I just make up a time that it took? Why not? How many hours do you think it took them to run 50 miles? 1 hour? They're super zoomy? One is easy. Okay. So we are assuming these are ridiculously quick people. And we're going to set time to equal, time 1 equals 1 hour. All right. So can I figure out how speedy each of these people are now? All right. So first place is legitimately running at 50 miles an hour. So the speed of a car. So rate 1 now equals 50. Rate 2 is going to equal 49. And rate 3 is going to be 46. What am I doing? All right. I need to figure out what is the distance between second place and third. All right, so our third place person is at some random distance, and that's at time 2. So rate 3 times time 2. All right, we're trying to figure out where that third place person is. All right. So if I now know this rate, can I solve for time 2? All right, so I'm going to drag this over and say, okay, it's 50 equals time 2 times 49. So time 2 is 50 divided by 49. And then can I now mess with this bottom formula here? Because I figured out rate 3. So whatever that distance is equals rate 3, so that's 46, times 50 over 49. Flip. So what does that give me? So this distance is where he's at in terms of the race. We'll call it that. All right, so how many miles behind is he? 3.06. So 50 minus whatever D was equals 3.06 miles behind. Was that legal with me picking let me just figure out how freaking fast they were running, so I don't have to go through and figure out all these different variables. Is that legal? Yeah, if we're consistent with it, it's legal. All right? Easy enough? You like my little stick figure drawing? You know that totally helped.